Okay, so we just finished the lecture portion for the least common multiple, the LCM. Um, Again, I want to make sure that you understand that hopefully you're paying attention to what's being addressed in these sections over here. But if you're paying attention and looking at the few examples that we give you, it's time that we really need to start to work examples forward. I mean, starting the beginning LCM, possibly using the LCM to do problems that you're expected to be able to do at the Math 100 level. Right? Much of this material is the same material that you've seen in prior courses, including really going back to grade school with LCMs. Although this algorithm may be new to you, it's one that's really, it's something that you might be from a grade school perspective. But the bottom line is we need to review this to make sure I understand what we've asked you to do, which the bottom line of this material here is finding an LCM. So what we're going to do is we're going to start working examples. And examples we're going to start working are, related to what we just did in the lecture portion. So give me a moment to switch screens and we'll work one problem at a time. Okay, so the first question is just find the LCM. So what I'm going to recommend is, the technique, and the technique is going to be to factor. Now, I'm going to say over time, this is going to become much quicker, but right now, I'm going to write down, they want the LCM between these two terms. And the first term is 6x squared. The other term is 4x plus 12. And by the way, there's two terms in it. When I say terms, there's two expressions, I should say. So what do I want to do? I want to factor them individually. So for example, 6x squared, and this might seem crazy to you, but I'm going to say 3 times 2 times x times x. Now, certainly that's overkill, but it's okay. All right, let's do the next one, which is 4x plus 12. And what do you get there? Well, the 4 comes out, and we left off with x plus 3. Again, I realize for some students, it's just overkill. What's 4? It's 2 times 2, and we get x plus 3. Now, the LCM must contain those factors. So I like to go in order, and the first thing I see is 2. I'll write that down. It must contain it. The other factor I see is 3. All right, I see the 3. The other factor I see is x plus 3. The other factor I see is x. All right, so if you go back over the notes and say it must contain those factors, this is where a lot of students trip up. And here's what it says. The maximum number of times it occurs in any one factorization. So let's look at the 2. What's the maximum times it occurs in any one factorization? 2 times. Let's look at the 3. The maximum number of times it occurs in any one of those factorizations once. All right, so I put it in black. Sorry about that. Okay, let's look at the x now. The maximum number of times it occurs in any one of those factorizations, and that's twice. Right, the maximum number of times the factor x plus 3 occurs in any one of those factorizations, which is once. Of course, I want to simplify this. The reason for that is it just doesn't look right to me. 2 squared is 4. 3 to the first power is 3. 4 times 3 is 12. X squared, x plus 3. I want to go back to the key, and I'm hoping that you're willing to do that as well, to verify that what you're saying is true. Now, someone's going to say, do I need to do all that work? I don't know, but the bottom line is you need to get that LCM, least common multiple, right? 12x squared, x plus 3. Let's go to the next page. And again, it's another LCM problem, all right? So what I'm going to do is I'm going to write it down for you. They want the LCM between those two terms. So they want the LCM between these two terms. So I'm going to say it's already factored, and I'm going to write it down now. And I'm definitely seeing a factor of 2x minus 1. I'm seeing a factor of 3 minus 5x. And I'm seeing another factor, x minus 5. Okay, so I see those factors. Let me point out to you. I see the factor 2x minus 1. I see the factor 3 minus 5x. And I see the factor x minus 5. Now, this is the part where students get tripped up on. All right, so let me just repeat. The maximum number of times the factor 2x minus 1 occurs in any one of those factorization. Right over here, the maximum number of times is actually twice. Okay, let's keep going. Let's do the 3 minus 5x. Well, that only occurred once. All right, how about the factor x minus 5? It only occurred once. So I know the LCM now. I'll write it down for you. It's going to be 2x minus 1 squared, 3 minus 5x, and x minus 5. I can put a box on that. No, you don't need to multiply it out, but I want to check it. Worked out beautifully. All right. Now, number 3, what they want is the LCM of those two polynomials. Well, my first goal is to factor those polynomials. So let's take a look at the first guy. And I'm hoping it's going to be easy for you. And again, if you haven't been practicing enough, start to practice. So 2x and x, 3 and 1. And what do you get there? 2x squared. Looks like it would work. And I'm going to say minus minus now. Let's see if it works. And yeah, what do you mean it work? Does it work if I multiply it? 2x times x, 2x squared. That would be minus 6 minus 1, which is minus 7x. And minus 1 times minus 3 certainly is plus 3. Let's factor the other polynomial. And I'll write that down for you. So it's going to be 2x and x. And it's got to be 1 and 1, right? Let me clean that up a little bit. All right, let's take a look. I got to get that to work. So I'm going to say plus and minus. I'm going to check it though. 2x times x, 2x squared. 2x minus x is going to be x. That worked beautifully. And you do get minus 1. Right, what do I have to do now? Well, I got to write down the factors I'm witnessing over here. Let's write them down one at a time. So what do I say? I definitely see 2x minus 1. I definitely see x minus 3. And what else do I see? I see x plus 1. All right. I'm going to underline this for you. I see 2x minus 1. I see x minus 3. And I see x plus 1. All right, let's discuss this one at a time. What's the maximum number of times I see the factor 2x minus 1 in any one of these factorizations? Well, at most once in any one of those factorizations. So it's down enough times. How about x minus 3? Once in any one of those factorizations. How about x plus 1? It's down at most once in any of those factorizations. So I got my LCM. I put a box on it, and I'm going to check it. How do I check it? I look at the k. All right, let's look at the k. It says 2x minus 1, x minus 3, x plus 1. Okay. Now 4 looks a little different to me. Now I'll tell you what it says. It says find the LCD. The LCD is the LCM of the denominators, where the denominators x and x squared. What factors do I see? X. What's the maximum times it occurs in any one factorization? Twice. That's the LCM, right? What's the LCM of the denominators? It's the LCD. What's the LCD? X squared. That's done. Let's do the next one, number 5 now. What does number 5 say? Find the LCD. What's that? Least common denominator. What is that? That's the LCM of these denominators. And what's the denominator? X, x plus 7. What's the other one? X plus 7 squared. Let's write this down. What factors do I see? X, and I see the factor x plus 7. What's the maximum times the factor x occurs in one factorization? Once. What's the maximum number of times the factor x plus 7 occurs in any one of those factorization? Twice. So this now is my answer. Whoops, it's not the answer. I got to back up. I didn't read it. What did it say? Rewrite the fractions. So they both have the LCD. So what I got to do over here is I have to rewrite these fractions. Let me do that for you. The first fraction is a squared over x plus 7. What we need to do for this one over here is we need to multiply the bottom by x plus 7 to get the LCD. All right, that would give you the LCD. If you multiply the bottom by x plus 7, you must multiply the top by x plus 7. We'll do that later. Let's put the next fraction down. What is it? A over x plus 7 squared. Well, what's the missing factor? Again, you need to focus on the LCD. What's the LCD? It's x followed by an x plus 7 squared. Well, I got the x plus 7 squared, but I don't have the factor of x. If you multiply the bottom by x, you need to multiply the top by x. So let's do it. Let's go for it. And what are you going to get over here? Well, the bottom in both cases is the same. And what is it? X times x plus 7 squared. X times x plus 7 squared. I'm going to circle that for you. This and this are both the same thing. Now, tradition has it, we need to multiply out the top part, the numerator. And what do you get? A squared x plus 7 a squared. Let me point out what I just did here. I multiplied this. Let's do the next one. Next one's pretty easy, just ax. I'm going to put a box in this indicating that's my final answer. And let's check it. And what do you get? Let's look at it. You're getting a squared plus 7a squared. I'm sorry, a squared x plus 7a squared. And then bottom, you get the proper bottom. Let's do the next one. And you got that one right too. Everything's looking fine. All right, let's keep moving forward. And this one says, rewrite the fractions in terms of the LCD. Those are the same type problem. So what do I need to do? I need to get the LCD. So what's the LCD? The LCD is, well, I have to look at, it's the actually the LCM of the denominators. And that's going to be x minus 4. The other denominator, factor, its factor, is x minus 4 times x plus 4. So what's the LCD going to be? Well, it's the LCM of those two things. So I see the factor x minus 4, and I see a factor of x plus 4. Right? We're not trying to confuse you, but I see these factors. Okay. Maximum number of times the factor x minus 4 occurs in any of those factorization is once. The maximum times the factor x plus 4 occurs in any one of those factorization is once. We got the LCD. Oops. I'm not going to put a box in there because they didn't really ask for that. They asked me to rewrite these guys. Let's write this down now. So it's going to be 3x. So I got to go back to black. We'll do it one step at a time. And we would like you to take a step also. Factor the denominator. What's the missing factor? It's the first guy, x plus 4. Let's do the next guy. 5 x minus 4 x plus 4. This guy's not missing anything. Let's go through it. And what do you get over here? X minus 4 over x plus 4. What do you get on top? 3x squared plus 12x, comma, 5 x minus 4 x plus 4. It's a great answer. For those students who want to write a simpler answer down, let me do that for you. Both answers are completely acceptable. When I say simpler, the bottoms really are simple if you multiply them out. However, do not feel obligated to do so. This will be x squared minus 4. I'm sorry, minus 16, I'm sorry. Comma, x squared minus 16. What do you get on top? 3x squared plus 12x and a 5. Right, I want to go to the next page and I want to look at the answer they have down there. I'm going to pull it over and I want to go back. I'm going to pull it back so I'll make sure you can look at this. I'm going to go back a page and I'm going to take this. Whoops, sorry about that. Paste it in. Blow it up a little bit. I want to see how I did. All right, it's important you look. No matter how good you think you're at this, you want to look. All right, let's take a look. Look at the top, 3x squared plus 12x, 5. Well, I want to point out they wrote this one down over here. They did not write this one over here. But again, I want to claim a lot of students would prefer to write down x squared minus 16. It doesn't make it any better or any worse. The only real requirement is to multiply out the numerator if it's not overly difficult for you. All right, you don't have to do the denominators. Let's go to the next page. And next page, really very similar question, a little more difficult. And what I mean by that, they're getting more difficult. All right, so let's write the LCD down. What's that going to be? The LCM of those two denominators. And I got to factor those denominators. Let's do the first guy. I believe it's going to be easy. It's going to be x and x. 15 would be, I'd say 5 and 3. And you should be becoming more comfortable with factoring. I want to make sure to me this, I'm trying it. X times x is x squared. 5 minus 3 is 2x. That worked out beautifully. And you do get minus 15. Let's keep moving forward. I'm going to factor the next guy. And what's next guy going to be? Well, let's take a look. It's going to be x and x again. And let's see, you got a 5. So it's going to be 5 and 1, right? Plus, plus. Just make sure it works. X times x is x squared. 1 plus 5 is 6x. And 5 times 1 is 5. It works beautifully. All right, let's write this down. I'm going to write the factors I see. I see a factor of x minus 3. I see a factor of x plus 5. And I see a factor of x plus 1. All right, let me go through this with you. I see x minus 3. I see x plus 5. And I see x plus 1. Now what's the next thing? Maximum number of times they occur in any one of those factorizations. Well, x minus 3 only occurs once in any one of those factorizations. X plus 5 only occurs once in any one of those factorizations. And x plus 1 only occurs at most once in any one of those factorizations. So this here is the LCD. Now what do I have to do? Well, I got to take the problem and rewrite it. And let's put that down for you. X minus 1. This factors to x minus 3. We just did it before, over x plus 5. Now what's the missing factor? Well, looking at it, there's an x minus 3 and x plus 5. It's missing x plus 1. We'll do that later. Comma. Keep moving over. I know it's a lot of work. We're trying to encourage you to do the work. X plus 5, x plus 1 times. Well, what's the missing factor there? Well, it's got x plus 5, x plus 1. It's missing x minus 3 now. I realize some students are disturbed that this is not in the same order, but I'd like to write them in the same order. So I'm going to write both fractions down, and they're going to have the same order in denominators. Now, you can multiply the bottom out, but I don't think it's a good idea. I'm going to write the other one down as x minus 3. I'm reordering it, by the way. X plus 5 and x plus 1. Numerators, generally speaking, should be multiplied out unless they're terribly difficult to do. But they look pretty easy. First guy's going to be x squared minus 1. And the second guy's going to be x squared minus 3x. I'm going to put a box in that and indicate I'm done. Now someone says, are you really done? I don't know. I'm going to check it. I'll get red. I see that. And it's different order, but I see the x plus 1. I'm seeing the x plus 5 and x minus 3. Let's see the second guy's right. X squared minus 3x, I see that. I see the x plus 1. I see the x plus 5. And I see the x minus 3. Worked out beautifully. All right, let's keep going. This one's a little different, by the way. Now, I want to tell you why it's different. I'm looking at it, and I'm noticing now it's not a common now, it's an addition symbol. So I still got to get the LCD, right? So what's the LCD? It's the least common multiple between 6x and 4x. Now, we've done enough examples. I'm starting to think that maybe you could probably do this by inspection for some problems, not all. And what would that be? Well, that would be 12x, right? What am I going to do? I'm going to put my builders in one step at a time. Right, here comes a problem. All right, so what do we got to do? What times 6x would give you 12x? Would have to be 2. So the builder is going to be 2 over 2. Remember, what you multiply the bottom by, you need to multiply the top by. What's 2 over 2? 1. It doesn't change the problem. What times 4x would give you 12x? Well, that would be 3. Let's write the answer down now. I should say the answer to the work. 12x, 12x. All right, both denominators are 12x. What do you get for the numerators? 8x, because 2 times 4x, 8x, minus 6. What do you get next? 6x plus 9. Well, now we have the same denominator. All we have to do is a numerator arithmetic. 8x plus 6x is 14x. Let's see, minus 6 plus 9 is plus 3. Get your red pen out, see if you got it right. We did fine. Let's go to the next one, number 9. And what I'm going to write down is the LCD is the least common multiple between 3x squared and x. And I'll write this down. What would that be? Well, it looks pretty simple. It's 3x squared. I have to put my builders in. And I'll talk about it. What times this would give you 3x squared? Well, 1. I'll write that down for you. Let's do this one. What times x would make it 3x squared? That would be 3x. What do you get over here? Both denominators now are 3x squared. What do you get for the numerator? X minus 2. And what do you get for the other guy? I want to point out what we're doing. We're taking 3x and distributing across the two terms, right? You get 3x squared, right? Because 3x times x, 3x squared, plus 12x. All right, this is where a lot of students are going to mess up. And I want to make sure you understand what we're talking about over here. We need to combine like terms. But the reason students mess up, they don't realize this subtraction symbol says subtract everything on top. So if you did that, you would get minus 3x squared minus 12x. And what do you get for the other numerator? You get plus x minus 2. I'm going to go through that work. We'll look at the answer key later. This would give you minus 3x squared minus 11x minus 2. By the way, this is a fine answer. There's no need to rewrite it. I will say some people are disturbed by the answer. So what they do is they factor out a minus 1. If they did that, what would they get? 3x squared plus 11x plus 2 over 3x squared. And that's just like writing this over here. Now, someone says, do I need to do that? No, the upper answer is fine as well. But take a look at the key though. What does the key say? Well, the key writes this answer down. All right, so take a look at it. Did I get it right? Got the bottom right, got the minus sign here, 3x squared, 11x plus 2. But I want to point out that answer is also fine. You just may not recognize them as being the same answer. They are the same answer. Let's go to number 10. Again, I want to point out there's little videos on the side for students that need to watch the video instead. Sometimes lectures go too quickly or students can't comprehend what's being said to them. All right, you can always rewatch the lectures and you can always come by and get help. All right, let's write this down again. I'm going to write down the LCD. What's that going to be? The LCM of the denominators. Again, I guess I could go through that algorithm of, writing the factors down, but I'm kind of looking at it. I'm saying, between 8 and 12, the factor there would be 24. Then x squared and y, and that's the LCD. So what I want to do now is I'm going to write down the builders. Slowly go through it. What times this would give you this? Well, I'm going to say 3y. If you multiply the bottom by 3y, you need to multiply the top by 3y. And why is that? We don't want to change things. And 3y divided by 3y is just 1. All right, let's look at the next guy, which is 12xy. We want it to be this. What do you need? You certainly need a 2. Because 2 times 12 is 24. And you need another x. All right, let's go through this. Now, what I want to claim over here is I'm doing this thing over here. The denominators are identical in both cases. It's 24 x squared y. And what is that? That's the LCD. It's the numerators that disturb me. So I want to do one at a time. I'm going to do this. And what would that give you? That would give you 3xy minus 6y. Now remember what I was saying about this. This is what most students are tripped up by. So I'm going to write it down for you. And what is it going to be? Minus 2x, yes, I'm commuting, times x plus 7. Again, if you can do this quickly, do it quickly. If you take your time, and you need to take your time, just please take your time. We'll look at the key later. So 24 x squared y, 3xy, minus 6y. Now what do you get here? Minus 2x squared minus 14x. There are no like terms. I'm done. What do I recommend? Please look at the key. I'm going to grab it. I'm going to copy it. I'm going back to the other page. And I'm going to paste it in. See how I did. Oops. Sorry about that. One step at a time. We're grading now. Did I get the right denominator? Bingo. Did I get the numerator? 3xy minus 6y minus 2x squared minus 14x. Yep, we're doing okay. Let's go to the next page. And next page, we got one more problem to do. All right. So again, I want to point out it's really going to same thing over and over again. Of course, you need to practice this. And you might say, I didn't do enough examples for you. It's 11 examples already. And you're going to get some practice in. The practice is going to come in the homework. Or you need to practice that. You need to reaffirm your belief that you can do this independently of me. Not just simply look at me and say, gee whiz, that looks okay to me. No, we want you all to do this. All right, so let's put this down. We want the LCD. And what's the LCD? The LCM of those denominators. And the first denominator is just simply 2x minus 1, comma. The next denominator is just simply x minus 6. Looks pretty simple. I'll write this down for you. The LCD would be, well, I see the factor 2x minus 1, and I see the factor x minus 6. All right, let's try it. I'm gonna put my builders in. And I'm looking at it. And I see the factor 2x minus 1 here. I need a factor of x minus 6. Remember, if you multiply the bottom by x minus 6, you must multiply the top by x minus 6. Let's do the next guy. What's the missing factor? 2x minus 1. All right, let's go for the work. And someone says, what is the work? Well, one is to know that the denominator in both cases is identical. It's x minus 6, 2x minus 1. We'll check with the key later. Now I got to do that numerator. And yes, you need to do the arithmetic. That's 4x minus 24 minus 5 times 2x minus 1. Going to keep working through it. The denominator, x minus 6 over 2x minus 1. We'll check the key later. What do you get there? 4x minus 24 minus 10x. I'm distributing the minus 5 across two terms, plus 5. I can do some things there. And we'll look at the key later. 4x minus 10x is minus 6x. Minus 24 plus 5 is going to be minus 19. There's nothing wrong with that answer. What I'm going to point out, though, a lot of times when you're looking at textbooks, what they do is factor out the minus 1. Let me do that for you. You get 19 plus 6x now. We could also write this as minus 19 plus 6x, x minus 6. We'll look at the key later. Like this. They also could write this one down. They're commuting the terms on top around. Again, someone says, do I need to write all those down there? No, but you just realize they're all saying the same exact thing. And what did they write down? Well, let's take a look at it. And I mean, really carefully look at it. I got the denominator in every single case. That's good. The numerator, what they write down, they wrote this one down. But really, every single one is the same one. Every single one is the same one. They just don't change. All right. So here's the deal. And again, we really can't say this enough times to you. We really want you to become, a participant in your educations. And what does that mean? You really have to be engaged with what we're asking you to do. And you got to get busy working. And this is perhaps the weakest thing that students have. They believe they don't have to work. Now, education requires tremendous work. All right. The amount of work you put in is going to translate to the quality of education you're going to get. All right. So do the homework. After you do the homework, you may have to go look back over the notes, make sure you understand what was presented to you, and then do the web assignment. All right. Thank you for attending.